I'm going to place it here by looking up. And see where it's situated. So it's starting 3.
I mean,
You're welcome to come to more than one, if you're interested in one, you certainly don't have opportunity.
Yeah, yeah, we were.
Oh, my kids have
And
worked
then,
for a while.
really?
Yeah.
And then I went to CPA first, and she came like 2 years after.
Right.
Yeah.
Yeah, she came when they started the open.
Okay.
enrollment, yeah.
Yeah, yeah.
I was thinking about that, so when it's open, it's not like this.
do whatever she wants.
Yeah, yeah, I don't know very well. I've talked to her a few years ago.
Only when you've window water. I want to send my children into the cleanup.
They have,
Oh, yeah, I got the next semester tomorrow too. We're good.
Yeah, I've already done it, I feel the need to, like, they won't be work for me at home, so I'm gonna give them an opportunity to do it at large.
we have this thing in our house where it's like, you either go to judo with dad
Uh-huh.
on Tuesday, Thursday night, or you stay home with mom and do chores.
Right.
And we do fun things like wash all the doors in the house.
Oh, the deep cleaning, I would so enjoy that. I would encourage them not to go to judo.
Sometimes it's like I've only had one taker on this day home for chores, and then the next session he was like, going back to judo.
And like the baseboards.
Yes.
and-
I'm totally like, if you're staying home with me, we're working.
All the jobs you never did.
All the stuff done that you would never think to get done. Okay, alright guys, it's about 11 o'clock, so we're gonna get started. It started at snack time. Please come and take something to eat. We have apples and oranges, we have bars and other different varieties. We have already, it looks like, more Rice Krispie treats have been taken than anything else. We have Rice Krispie treats. You are welcome to take more than one thing and take it in your food at the end of class, so you don't have to leave for the rest of the day. A big reminder that your next homework assignment, homework 5, which is about pollution and injustices that often go along with pollution, is due today at midnight. You can drop it on Blackboard. You're welcome to email it to me if you have a hard copy to turn in today. That's fine. Okay,
Yeah, I have a question about the assignment. On the EPA, we're like looking for your neighborhood by your
Yes,
zip code.
yeah.
Like my zip code pulled up 0 on
Awesome.
everything.
Like, tell me that.
Okay,
That's
so I was
fine.
looking for a bad zip code.
Yeah, when I put it in, I get like 5 cities, so I'm like, okay, everybody will have 3. And then Andrew was mentioning earlier, there were only 2 pollution sources that were in this particular neighborhood. That's fine, okay? If you feel the need to take a screenshot to verify that, that's fine. But I trust you that if you've looked, maybe there isn't anything terrible happening in your neighborhood. On the bright side of things, right? Or,
Noise pollution.
This is one of those things where you have fewer things to tell me about. That's probably. Okay. All right. My other logistics is that Tuesday in this class we're having a guest speaker.
Fancy.
Okay. I know, super fancy. Her name is Vanessa Hanna, and she is the executive director of the Valley View Foundation. And they work here in Claremont County. They have a land management area that they manage for conservation and preservation purposes. And so she's going to come in and tell us a little bit about her organization, a little bit about the outreach activities that take place on their property and that she's involved with. She's always been really interested in this class and getting us out to the property. She's the one that suggested our next service learning opportunity, which is going to be on April 13th. When you come to class on Tuesday, I will have a full lunch for you. Okay? Chips, fruit, sandwiches, cookies, bring your own drink, okay? Not alcoholic. I've met Vanessa several times and she's very engaging, but I don't know how her presentation will be, so we will see. You'll have a little worksheet that you can fill out if you were with me last semester for our guest speaker we had last semester. It's very similar. It'll tell you a little bit about what you learned, tell you questions that you have. You'll definitely have an opportunity to interact with her and ask her questions about what she's doing. I encourage you to come and eat lunch and pay attention. It will be a good prep work for our last homework assignment in class, which I mentioned a few times now, and which I'll have available for you next Tuesday. The last homework assignment in class is going to be for you to come up with a proposal related to one of the service learning sites that you have been to or that you've heard about in class. or the one that Vanessa presents to you in the Valley View Foundation, and come up with an idea of what the next thing is that they should do. How can they better engage specifically, you see Claremont students, you know, what did it look like they needed at their property? I'll give you a budget, you have like $1,000, you can spend a little bit of money on this proposal. Come up with something that you would like to do in association with these groups that would further either the missions of the actual foundation, the site, or that furthers what you have learned about here in class and what you've gotten involved with through the semester. Okay, so interacting with her will give you another set of options and ideas of what you might like to do for your last hour. Okay. On definitely our schedule of events here as we come down to the end of the semester, one of the things was like, you're going to do a normal presentation about this homework 6 in class, and I'm like, I don't think I need you to stand up and tell us about it. We might give you an opportunity to talk about your proposals in small groups on that day, but I'm more focused that we talk about climate change and less that you practice your oral presentation skills, which is the main purpose of that. So we will not have to do an oral presentation in this class. We're, like, something is coming off your schedule at this thing. Okay. All right, this leads us to, we're going to talk about air pollution finally today, and it leads right into the last thing that I have on the board here, which is that our third and final service learning opportunity is going to be at Stonelit State Park, which is here in Claremont County. It's about 25 minutes from campus, I think. It's like 35 minutes from my house out in Mason, it looks like. And we are going to participate in Claremont County Spring Litter Cleanup. And so I don't have the specific details about where we're going to meet at Stonelit State Park. That's what I'm waiting on giving you little information sheets about. They should send me that information this weekend. But I have signed us up to go there. You can sign the little sheet that tells me that you're coming, and there are 2 permission slips, one for the university, one for the cleanup organization that we're going to be involved with. My expectation is that we meet at 9 a.m. They're going to give us some things that we need in order to pick up litter, and then they're going to release us onto the parkway. And you can go in whatever direction you would like, and with whoever you would like in the group in order to help out. I'm not positive about the end time, but my expectation is that we do about 3 hours of work. And so if you need to leave at noon and go on to other things in the afternoon, that is my expectation, and that's what I would be communicating to the people that are involved. I think the first 10 of us that come get a t-shirt. But I didn't run us any excuse. We're going to stay on land, and no one's going to fall in the water. Okay, again, everyone is welcome to come, even if you've participated in a service learning project already. You must participate in one, okay? And so if you cannot make it to Saturday on the 13th, then you are on your own to find a service learning opportunity that does work with your schedule. And volunteer.uc.edu has a full website of a whole bunch of different opportunities that you can engage in. Just let me know what you sign up for, and let's have it done by the end of the semester. Because that leads to your homework 4. Okay, that you also need to. Okay, any questions about class logistics? We have a little bit today. So again, Tuesday, we're all going to come in, we'll grab lunch, you'll get the little worksheet, and Vanessa will talk to us about her organization. And then next Saturday, we'll do our last service learning. Cool, all right. All right, we today are going to talk about air pollution finally. And we've been building up to this, of course, for a couple of weeks now. What we're going to focus on today and next Thursday are air pollutants other than carbon dioxide. And again, the main sources of air pollution that we find are transportation and the burning of fossil fuels for a variety of different purposes, as well as certain industries, smelting processes, mining processes. We're going to learn about all different types of compounds that become volatile as they evaporate, that we utilize in building homes and maintaining homes and businesses. Those are the topics of our air pollution here for the next couple days in class. The picture here of lichen is very interesting. Lichen happens to be cool. Lichen is a symbiotic relationship between a fungi and a cyanobacteria, and they happen to be very sensitive to air pollution for one reason or another. And so the types of lichen that grow in a particular area are indicative of the load of air pollution that place experiences. And only very resistant symbiotic relationships can exist in places like Los Angeles, and Pittsburgh, and Philadelphia, and London, and Beijing, and China that experience a lot of air pollution. So the changes in density and species composition of the lichen community is often a first indicator for people that are out there looking at air pollution. And then we set out a whole bunch of different types of filter collectors, essentially, that suck in air and deposit air pollutants on filters that we then take in the lab in order to measure the amount of air pollution. We know what volume of air kind of got sucked through the filter over a given period of time. You can then extrapolate that to how dense air pollutants are in the environment around us. In places like Cincinnati, what are the types of air pollutions that we generally experience?
Chemical,
Yeah, chemical or anything else that you notice that's in the atmosphere around us?
We have some smog.
We have some smog, good. On what days does it tend to be smog? Hot days, okay? So usually during the summertime, you'll be driving down the highway and you'll get that like smog warning that's like, hey, don't fuel your car between the hours of 8 a.m. and 6 p.m. You know, try to fuel your car. We're going to be releasing these volatile compounds into the atmosphere on times when we're not actually out there doing a ton of driving. That helps dissipate these air pollutants. What else do we notice in our area?
Well, there are allergies, there's a lot of pollen, but that's not
Good.
pollutant, but that's.
It is, and that definitely counts. So think about, we tend to think and associate air pollutants with these human-induced causes of air pollution, which are a portion of it. But in many of the cases, these air pollutants that we're going to talk about, 2/3 of them or so, half of them are produced from natural sources. We have volcanoes, we have dust storms, we have different plants that are blooming at different times of year. Those things are air pollutants. They are things that affect respiratory health and overall health of organisms and the ecosystem around us.
So they all go into like, on the news in the morning, we'll see air quality.
Oh, yes.
So like the organic and the.
Yep, all of that is kind of put into that air quality factor that's on it. What else? I live next to a kind of a farm. They don't farm it real intensely. It stinks, right? There's all these different odors that come. Sometimes you smell trash, sometimes you smell manure, sometimes you smell freshly tilled earth and fertilizer that's been put down. All of those things, and again, you can think of them, they start on the ground, and parts of them end up in the atmosphere, and then they get spread across and around the environment. They get spread around the environment. And that's another factor I want you to think about with air pollution is that it spreads very, very easily. Like water pollution, it easily travels from the place where it is produced to another location. And that creates a lot of the problems that we have with air pollution in that it appears dispersed and taken care of at the smokestack where it's produced, or at the factory where it's produced, or at the landfill where we're doing some type of burning or trash incineration or methane capture and production. But it's still up there. Those particles remain in the atmosphere for different periods of time. Again, we can talk about persistence of some of these compounds. And they influence not only the location where it's produced most heavily, but other people, depending upon the wind patterns. Okay, so we're going to talk about these different guys today. We're going to start very simply. We talked about the structure of the Earth. We can talk about very, 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 very briefly the structure of Earth's atmosphere. There are several layers to the Earth's atmosphere, going and extending all the way out into space. We are most concerned with the two layers that are closest to the Earth. Okay, and again, the analogy that our textbook takes, or the metaphor our textbook puts in place, is that you have an apple and you think about it. The thickness of the atmosphere is actually pretty thin when it comes to all of the jobs that the atmosphere does for us. And the oxygen it contains, the UV and solar radiation protection that it provides for us. On that apple, if the apple is, or the skin of the apple is like the thickness of the atmosphere. We talk about the troposphere and the stratosphere being several miles thick, and that's true. But it's actually very, very thin in terms of the immensity of space, and kind of compared to the total kind of radius and diameter of the Earth. Okay? Most of the types of air pollutants that we're going to be concerned with are going to be ones that appear and remain in the troposphere, which is the layer of the atmosphere that is closest to the Earth. It's the thing that's surrounding us right now. It extends up to about 5 or 6 miles above the Earth's surface. And so, this is the layer of the atmosphere that we're flying around in our airplanes. This is where we're releasing all of these pollutants. This is the place where a lot of our dominant wind patterns take place that are moving things both on a climactic scale from the equator towards the pole and back, but then also from places of pollution production over to places where that pollution is going to end up depositing. The troposphere is the densest layer of the atmosphere. It contains, it's the densest is at the bottom. It's just like water is dense in the sink, and light things float. So most of the molecules of the atmosphere are present in the troposphere, represent 70 to 80% of the atmosphere's entire mass. The molecules are most tightly packed here. You may be familiar that if you go up in elevation, if you go up into the Rocky Mountains, the air gets thinner. And it gets less dense. That means that there's a lower oxygen concentration for every breath that you take, and you may experience shortness of breath or altitude sickness as you change the density of the air around you. That's definitely a factor in the layering of the Earth's atmosphere. 78% of the troposphere is composed of nitrogen atoms, 21% is oxygen. There's a smattering of other molecules that make up measurable portions of the troposphere on any given day. We've got argon, we've got carbon dioxide, methane, water vapor definitely. We have soot actual particles that we can see and observe and capture. We have ozone, which is O3, and we have nitrous oxide. The next layer up is the stratosphere. And it goes from about 5-6 miles above the Earth's surface all the way up to in that kind of 30-mile range, okay? It is less dense, it's lighter than the troposphere below it. And the major components here, again, are nitrogen and oxygen and water vapor. And this is also the location of what we're going to call the ozone layer. So we have actually a relatively high density of O3, kind of at the bottom of the stratosphere, the top of the troposphere. And it helps to protect and absorb ultraviolet radiation that's coming from the sun. And it's one of the things that has consistently, along with the presence of water on Earth, helped make life possible on our planet by protecting us from this type of radiation. You may be familiar that the ozone layer is thinning, particularly over the Antarctic, and to a lesser extent over the Arctic Ocean. And we're going to talk about why that is and some of the really important changes that have been made that have ended up resulting in a thickening of the ozone layer in these locations where it traditionally has been thinning or producing these ozone holes, as we were very familiar with it in the 1980s and early 90s. Yeah. Oh yeah, back in the days of Harrisburg. All about the bangs. Totally. There was a girl in my class that she did her bags like she rolled them half down and half back up.
Has any one child in the 80s been?
I know. We just watched it.
We're sturdy.
I wonder what happened to Lindsay.
She's probably still sporting those bangs.
She might still have those things. Okay. Like other types of pollution that we have encountered, we can define air pollution as a concentration of anything that is high enough in order to cause harm or damage to humans, to ecosystems, and in the specific case of air pollution, it's any high enough concentration of a molecule that can influence climate, that can result in climate change. And that lets us expand our definition again of air pollution to be able to talk about carbon dioxide and its impact on climate. And it also lets us talk about these very traditional types of molecules that are harmful either directly to humans or because of the interactions they have with other molecules in the atmosphere, and usually sunlight, they produce things that are harmful to the environment around us. Things like acid rain, things like sulfur dioxide, the production of a couple different types of smog. Okay. So the presence of chemicals and concentrations that harm organisms, ecosystems, materials, or alter climate. And again, there are natural sources of most of these types of air pollutants, including carbon dioxide. So we talk about volcanoes, Here we see a large volcano and the smoke plume coming out of it that happened in 1994 as an example of air pollution that comes from some of these natural sources. Wildfires, we had all these amazing satellite pictures of the wildfire smoke plumes the last couple of years in California and how it's impinging air quality, not only in California, but then as the wind blows it up the coastline, places like Portland and Seattle had days when they could see the smoke from these wildfires, both in the kind of the Oregon, Washington area, as well as being blown up from California. Okay. We have tremendous areas covered with sand and dust on the planet, our desert ecosystems. When the wind blows over those areas, it naturally picks up the particles and carries them to other locations. This is really important for fertilizing the ocean for phytoplankton growth. But on land, it provides fertilizers to places like the Amazon River Basin and the Orinoco for primary production, but it also gets into the respiratory tracts and the tissues of living organisms where it can be problematic. And as desertification occurs, as we transform more of our grasslands into deserts, these types of dust storms and the respiratory elements associated with them become more common and problematic. Plants can also be natural resources of air pollutants. In addition to plants giving off water vapor during the day, they give off a whole suite of different compounds, some of which can be very irritating, like pollen, okay? And all kinds of different volatile organic compounds come out of their stemma at various different points during their life cycle that can contribute to this problem. And then we have our human kind of anthropogenic sources of air pollutants. Most of it is related to burning of fossil fuels, either in industry, in transportation, and electricity generation. That's the main source of what we're doing. We're going to recognize that not only do we get carbon dioxide out of these processes, but we get things like our nitrogen oxides and our sulfur compounds that also come from fossil fuels that are a main contributor to some of these big problems with air pollution. Okay, so there's natural and there are human-induced causes. Okay. All right. We can start to define different types of air pollutants, and the ones that we're going to encounter, as I mentioned earlier in class, I want you to kind of keep in mind that some of them are directly released from these sources, and some of them have to go through a variety of different chemical reactions before they become problematic, before they become less harmful. And this gives us two classes of air pollutants. Our primary air pollutants that are directly emitted from a source. So if you have a tailpipe emission that contains carbon dioxide, carbon monoxide, sulfur dioxide, that's a primary pollutant. That's exactly what is coming out of the process. You have a volcano that is exploding, you have soot and ash that's being released, you have also carbon dioxide and a variety of sulfur compounds that are coming out. Those are the primary pollutants. The secondary pollutants are what happens to those primary pollutants after they've been exposed to the atmosphere, to sunlight, to other molecules in the atmosphere, to each other. They've interacted with precipitation. That gives you a secondary pollutant. So a secondary pollutant are chemicals that are formed when these primary pollutants react with each other and natural compounds. In our picture here, we have our tailpipe emissions, and we have our volcano, and we have our factory, and they're releasing certain primary pollutants. Those things can be transformed into each other, and they can kind of interact with one another. Carbon monoxide can become carbon dioxide, and vice versa. And you get a suite of other things. Mostly we get out of these types of processes our actual sulfuric acid and our nitric acid that contribute to acid deposition and acid rain, acid precipitation. Finally here is the persistence of these guys. And we've been talking about persistence as it relates to solid waste in large part this semester. Because of global wind patterns and because of precipitation events, most air pollutants, either primary or secondary in the atmosphere, in the troposphere, exist up there for about 2 weeks. That's different up in the stratosphere and in the ozone layer. We have a different air pattern and different persistence for what's happening to these molecules. So most of these molecules, they go up and they come back down within about 2 weeks. And so this again, remember this idea of cycling, okay? What we do here on the land goes up into the atmosphere and then it comes back down again. And again, we can use use it in different varieties and different forms, it has to be taken care of or cleaned up in certain ways. And then it becomes land pollution, water pollution sometimes when it comes back in. So these things are tied together in these types of cycles. Where that pollution ends up is very dependent upon the local geography, the local wind patterns, the local precipitation patterns. And that might vary season to season. Okay, sometimes it comes down very quickly, very close to where it was produced. Sometimes it gets spread, honestly, from the equator all the way up to the poles before it comes back down. And again, it is chemically dependent. Some of these compounds react and come back down very quickly. Some of them last for a really long time up there in the atmosphere and are much harder for the atmosphere essentially to cleanse out. Okay. All right. So, we have a couple things that help us reduce air pollution and that work to our advantage and have done so throughout the geologic history of Earth. Okay. What is taking these air pollutants naturally out of the atmosphere is gravity. These molecules, in some cases, are heavy or they easily glom onto particles in the atmosphere. Those particles then are the nuclei for precipitation, and they get rained out or they literally fall down to the ground. Okay? Everyone has been around a bonfire. You know that the little particles go up and they float away. The big chunks of visible ash, they float for a little distance and they fall out. They're heavy, okay? So gravity helps us pull these things out of the atmosphere, as does precipitation. Sea spray is another good cleanser of air pollution. Sea spray puts water molecules up into the atmosphere where different particles and molecules get attached to them. Then when that salt spray lands back down on the earth, it brings with it all the air pollution in the region. And so essentially, very often you find that locations where you have high wave action, where you have rocky shoreline, tend to have a little bit better air quality. So you get some advantage when the sea spray helps you get stuff out. Okay? Winds, of course, help to move air pollution and distribute it. They help to spread out and disperse air pollution so that they are in the lower concentrations. That will be less particles to organisms in the environment. They give it a chance to move from that high concentration where it's produced to lower concentration when it finally rains out or gets deposited as particles in the ecosystem around us. And the last thing that helps us out when it comes to air pollution are some natural chemical reactions, things that take place between water vapor and sunlight, other molecules in the atmosphere that grab some of these harmful particles, break them apart into less harmful compounds, and get them in a state that's easy to be rained out and be less harmful when it does so. There's always a scale though, and it's going to vary on your particular city and your particular location, whether or not you have lots of these factors that are helping you clean your air, or if you have none of them. And so in general, places that have very stagnant air, that have low precipitation, tend to have the worst air quality in lots of cases because they don't have some of these natural reducers of air pollution to help them out. It also tends to be a little better in cooler climates and warmer climates that enhance air pollution. So again, kind of as you get into temperate cooler waters, it gets a little easier. Just like there are some things that help us reduce air pollution, there are certain natural factors that enhance air pollution, that make it worse. Okay? And many of these are not just natural, like mountains and ridge lines that prevent the movement of air, kind of block air pollutants from getting dispersed, but human things that mimic those natural inhibitors of air pollution removal. So buildings tend to enhance air pollution and the concentration of molecules. Buildings, like the skyscrapers in downtown city cores, block the movement of wind, and thus they remove that natural disperser of air pollution. They create still areas. They create locations where the wind blows very, very strongly through certain areas, but then doesn't touch the alleyways in between the buildings. And so, again, classically, our urban core ecosystems, our urban environments tend to have very high air pollution because we have lots of sources of air pollution, and then we've removed some of the natural ways of dispersing it. Hills and mountains act just like buildings, and they block the air dispersal. They can change and modify precipitation patterns, like rain shadows, where on one side you get lots of precipitation and air cleansing. On the other side, and all the water is out of the air mass, then it's much harder to remove air pollutants from precipitation. Again, high temperature tends to increase the number of reactions that take place to produce some of our secondary air pollutants. High temperatures tend to exacerbate the use of electricity and the production of their primary air pollutants in the first place. Volatile organic compounds, which is what C stands for, that's volatile organic compounds from plants can do some of our plants are going to do us some favors in that they take in air pollutants and help to cleanse the air. It's pretty much balanced by other compounds that plants take out. In general, in your home, having house plants has been shown to increase air quality and improve air quality rather than be on the bad side. But again, in certain cases, plants can be really problematic for people and organisms. The grasshopper effect is what I alluded to when I said that air pollutants can move from the equator to the poles. And the grasshopper effect is in reference to this jumping of air pollutants from the place where they are created to places where they are not. And the grasshopper effect are these vast global wind patterns, like our big ocean circulation patterns, that take air from the equator up into the upper atmosphere, and then when it cools down, it falls at the poles. And this moves air pollutants that are produced in the tropical latitudes all the way to the poles. For several decades now, pilots flying in and around the Arctic Circle have noticed that there's an Arctic haze. There is smog in the Arctic, even though nobody lives there and there aren't any factories there that are producing this type of pollution. These pollutants are being dragged by our global wind patterns into these more pristine locations. We know that certain types of compounds that are carcinogenic and are pollutants are found in Arctic organisms like polar bears and seals and the whales that live there in their fat layers where they've stored up compounds for several years. The only place they can be getting it from is from air pollution that is dragging it forward or from water pollution that's pulling it up from coastal. Okay, that's the grasshopper effect, this jumping of air pollutants from where they're produced to other locations due to our basic wind patterns. Okay, the last thing here that can enhance air pollution is what is shown in our little figure, and that is what we call inversion. It's an inversion layer. And so the vertical air structure can, in some cases, produce a layer of warm air kind of in the middle of the air mass. Okay? And this blocks then the cooler air below from being able to pop up and get dispersed away from the location. It's an inversion there. Usually, right, you have cold air at the bottom, and then you have warm air above it, and then you have warm air kind of all the way to the top. Okay, right, warm air is less dense. But in this case, you get cool air at the bottom, you get a layer of warm air, and then you get cool air on the top that acts like a lid on top of the cool air and the pollutants at the bottom. And that warm layer between is this inversion layer. And it acts like a lid on the air pollutants. It keeps them next to the ground.
Are valleys more susceptible to that, or is it just because they can't dissipate as well? To the development or the
things.
dissipation? 'Cause
Both things.
Salt Lake
So-
City Valley is
right,
awful.
exactly.
I lived there, never experienced it, went back to visit, and I was like, what happened? You can't see the mountains. You may as well be in Ohio.
Yes, exactly. That's an inversion layer. You get this situation where the wind blows up against a mountain or through the valley instead of like up and over the mountains, and it keeps the pollutants right there. This tends to happen in places like Los Angeles and Seattle, where you have ocean on one side and then you have mountains or buildings on the other three sides. And the cool ocean air blows in, but it can't get past the mountains. And the warmer air on top acts like a lid to just keep the cool air constantly pushing in for several days until the wind pattern changes, until you get a really kind of cool overnight that's able to pop that inversion layer. Happens in Salt Lake City too, again, where you have mountains on 2 or 3 sides that can create this little pocket where air pollution sticks. One of the reasons why Cincinnati has relatively few smog days in the summertime is because we don't have this type of geography that can create this type of inversion layer, this type of pocket. Okay, so we get lucky in that sense. Usually overnight it blows out, the next day it might be slightly hazy, but again, the next storm system coming across the plains kind of sweeps and cleans this out. Is that cool for everybody? Okay. Things that help us with air pollution, things that can really be problematic. What's interesting then is how different communities respond to air pollution is very dependent upon what they experience. And sometimes what they experience in terms of air pollution depends on their local community, their local geography can intensify it or can make it seem like it's less of a problem than it actually is. Okay. All right. The first type of air pollution that I want to introduce you to is what we call industrial smog. This is also known as gray air smog. It is what the people here at, what is this, the Forbidden City, right, in China are experiencing, where the air is grayish blackish in color. It's different than the photochemical smog we experience here usually, which is brownish reddish in coloration. This is definitely more gray-black in color in terms of what we call industrial smog. Industrial smog comes from the burning of fossil fuels in manufacturing and smelting processes, and largely today in coal-fired either home cooking or coal-fired electricity power plants. And industrial smog is formed of a mixture of sulfur dioxide, SO2, droplets of sulfuric acid, H2SO4, and these ashy particulates that come usually from burning coal or petroleum products that have this grayish black color. Again, the main cause of industrial smog is burning of coal in homes and industry and electricity production. And it was really problematic in early industrial Europe as well as North America. And today it's very problematic in China, where they continue to use coal as their major source of electricity generation. And so some of the air quality changes that have taken place in Europe and North America to clean up industrial smog are now what's underway in China as they started to have these really serious air quality problems. Most of the time, breathing this in irritates your respiratory tract, and you cough a lot because you're breathing in these sooty particles. It really contributes to acid precipitation and acid deposition with the production of these sulfur particles. We don't experience industrial smog today to a large extent for two reasons. One, we put in place a lot of filters in our coal burning power plants in order to remove exactly these types of pollutants. And two, because we build really tall smokestacks that send this stuff way up into the troposphere so it gets dispersed before it can settle down in cities and urban cores. Yeah, tell me.
Is it so bad in China because they burn coal so much, or is
Yes.
it because there's
It
like lack
is.
of wind or lack of?
No, it's entirely volume based. Yeah. The picture up here is actually of Pittsburgh in the 1950s and the industrial smog that they were experiencing. Like, that's not long ago, right, guys? Like, the 1950s, I mean, the video, maybe I'll go back and try to click on it in a second. The video what's happening in China is from, like, last year. You see this, like, smog layer rolling in. But even here in the United States, industrial smog was something that was very part and parcel with urban communities that were doing lots of manufacturing because they were burning and melting slag, melting coal on site, largely in terms of Pittsburgh for steel production. And they became a real problem for places like Chicago, Detroit, Pittsburgh, to a lesser extent, Philadelphia. Yeah.
Why is China like so far?
I would say that the reason that China is so coal dependent is first and foremost because they have a lot of coal. They're going to utilize the resource for electricity and power generation that they have. So they have a lot of coal, so like burn it, because that's what they've got. Two is that in the recent 40 years in China, they've had this huge economic push to become industrialized, to start providing basic electricity for most of their residents. Remember, this is a big country that has 2 billion people in it. So they've got to provide electricity, and they still haven't to all 2 billion people. That means they have to have a lot of coal burning power plants. And so they embarked upon this. Again, I want you to understand this with good intentions. Okay, they wanted to bring and improve living conditions for Chinese. Now they're saddled with some of these environmental problems that come with phasing out on fossil fuel industrialization. Okay, there are a variety of different reactions that take place in order to form industrial smog. Recognize that most of it is primary pollutants that comes from burning coal. Some of it are the secondary reactions. Okay, I'm gonna go back one. Okay, here's our little video of what's happening in, I'm pretty sure it's Beijing. We're up in one of the high rises, you can already see they have some smog here. And honestly, in the course of about 30 seconds, the industrial smog there will destroy.
It's a smog out.
It's pretty phenomenal what can happen in these types of situations. It is real time. It gets produced and then it blows into different areas. Definitely, if you are in these types of situations, these are the days when you wear your mask, do some work when you have to go outside because you can visibly see them in the sunlight. The Olympics that were held in China a few years ago have real concerns about air quality because this was happening on a day-to-day basis as industrial smog was rolling in, and they were really concerned about what's going to happen to athletes as they participated, how it would affect their performance, how it would affect these athletes long-term after being exposed to it for a couple of weeks. So they shut down the coal-burning power plants during the Olympics to help with air pollution production, so that they wouldn't endanger their communities to such a great extent. Okay. All right. The other type of smog, and what we tend to experience here in Cincinnati, is known as photochemical or brown air smog. And it is that classic brownish reddish haze that you see that develops around kind of late morning into late afternoon. This is a type of smog that is produced on a daily basis, and then depending upon local conditions and weather, it can sit and build up over the course of several days. It is a mix of primary and secondary pollutants. And the exposure of those pollutants to sunlight is key to the production of photochemical smog. You can always remember that UV and sunlight is a part of this because it's in the name. It has to be photo from light and chemical reactions to produce photochemical smog. Industrial smog comes out from coal burning and electricity production. Photochemical smog has to go through some, you can think of it almost as fermentation in the atmosphere before it pops up as problematic. In most places that have problems with photochemical smog, the morning commute and the tailpipe emissions coming from burning petroleum products in car engines and truck engines and train engines, plus the interaction of those primary pollutants with ultraviolet light in the early morning, so sunny days, hot temperatures, are what produces these chemical reactions in the atmosphere that reduces visibility and produces the brownish reddish haze that is so classic. It's sometimes both the New York skyline as well as places like Los Angeles and San Francisco. The hotter and sunnier the day, it intensifies these chemical reactions taking place. And so it gets worse on those sunny days during the summertime here in Cincinnati when we had those smog mornings. And that's when it happens. Yeah, good.
Does humidity have anything to do with it?
Not usually. Humidity actually tends to help in that then the higher the humidity, the greater chance of precipitation, which definitely helps remove this stuff from the atmosphere. I would say that humidity can be problematic for it in that when it is humid and hot out, we tend to turn up our air conditioning. And that contributes to the production of primary pollutants that then builds into photochemical smog. And so kind of the more electricity we're using, the more transportation fuel we're using, the greater the chance that you will have photochemical smog production.
Can you say that? Whenever I think of smog in like our area, I always think of like this little cloud.
Yeah, and then again, you definitely can think about it that way, and then again, when the wind starts to blow, it moves that cloud from us to somewhere else.
And it's usually like, when I see it on the news, it's usually like this big.
Okay. I'm there with you.
Is that like,
formed over downtown commuter cores, where lots of people are coming in, where there's lots of electricity usage, and the heat island builds up to intensify these chemical reactions.
You should notice on your commute, so like as you're on the interstate, and you see like the little valleys on the side of the
Yeah.
interstate, you'll see it a lot. That's going towards the city.
Okay, I believe. It's gross. That's how it's formed. That's where it's gonna stick. That's where it's gonna be problematic. And again, that's why people in some cases have moved to the suburbs to escape this type of photochemical smog that we produce. Again, in our temperate latitude, it's not really problematic in wintertime. In places that have a much warmer year-round climate, like in Los Angeles, Mexico City, they have problems with photochemical smog year-round. That is their kind of weather. Okay, all right. Any more questions or comments about smog? I'm going to tell you a little bit. I want us to talk about smog because it's something that we've all experienced. It is one of the main outcomes of these different types of air pollutants. I want to talk next about the human health impacts of air pollution. And again, you can kind of envision this as a smog problem, but I also want you to start to appreciate that for many people, the types of pollutants that they're exposed to are not only outdoor, like the industrial photochemical smog, but there are also indoor air pollutants that can be really problematic, and that particularly in industrializing nations, less developed economies, it's indoor air pollution. That's even more problematic than outdoor. They don't have these big power plants. They don't have big manufacturing facilities. It's on a combined basis. All right. So what's problematic about air pollution? Really, it has almost everything to do with your respiratory system. And these particles and compounds, not just kind of these particulate material, but even compounds like carbon monoxide, they enter your body through your respiratory system. And you actually have a ton of defenses in your respiratory system that are designed to help you clean out and keep these things from becoming problematic. Your respiratory system makes a ton of mucus, you may be very well familiar with, that is designed to catch this stuff and help you expel it. You have all kinds of little cilia all throughout your respiratory tract that help you manage that mucus if they're working properly, and that are designed again to glom on to these compounds and these particulates, get them stuck in the mucus, and then get it working out of your system. You ventilate your respiratory system many, many times a minute. Okay, you breathe in and you breathe out. So if you're doing yoga and they're like, hold your breath, and you're like, I want to breathe. Okay, all these things are designed for you to flush out air pollutants from your system. Air pollutants become problematic when you're exposed to them very acutely. You experience a really high dose of air pollutants, like you're walking through downtown in the industrial smog without a mask on and you're inhaling a ton of them. Or if you're exposed to air pollutants chronically, which is what the articles that you were reading were dealing with for the homework assignment, where day after day after day, you're exposed to a certain load of air pollutants that eventually overwhelm your respiratory defense system and wear down your immune system in responding to them. Okay, so chemicals and particulates enter and they tend to lodge in our lungs. They can clog your lungs and actually reduce air volume and ventilation, exchange of oxygen and carbon dioxide across your lungs. And in many cases, these compounds and even some of these superfine particulates are capable of diffusing from your lungs into your bloodstream. And in that way, then they can travel throughout your body. This is definitely the case in lead air pollution that used to come from burning leaded gasoline. And that the lead particles ended up in the atmosphere, and then we all breathed them in, and we got lead in our bloodstreams. This is why today you buy unleaded gasoline and diesel when you go to the gas pump. And it says it on the label, and it's always like unleaded, and you're like, was it ever leaded? Like, why do we need this adjective? And yes, we used to put lead in gasoline. It helps with the fuel efficiency process. But it ended up poisoning our kids in particular by increasing lead in their bloodstream to unacceptable levels. And so that one change in our laws for regarding air pollution, we went from 85% of kids in the United States having unacceptable lead blood levels to like 1% of kids in the United States having unacceptable lead in their bloodstream. Although today we recognize that any lead can influence the staff, usually. I saw it first.
Well, is radon considered a pollutant?
It is, and we will talk about radon as a major indoor air pollutant. Will, that's another one that causes pneumonia.
Is this why they have like the asthma alerts?
Yes.
Like,
Yep.
I had really bad asthma.
Yeah.
My mom's really watching.
Yeah,
I was going out outside too.
yes, exactly. This is exactly it. Yes. Yes, exactly. These air pollutants particularly, they can be damaging to healthy people, and then for people that already have respiratory illnesses or a weakened immune system, newborns, asthma sufferers, people with emphysema or cardiopulmonary disease already. That's what the air quality index is all about. They're trying to warn you that you need to be indoors in a clean, filtered environment because air pollutants are too intense outside. Caleb?
Why does it still say unleaded if it's a law?
Who knows? It's not like they sell leaded gasoline in the United States
That's what I
anymore.
mean.
I don't know.
Gas stations are just labeled as regular now.
But now maybe they're changing. But it's not like we're getting leaded gasoline.
Yeah.
Did they sell lead gasoline?
Yes, they do.
Ew, where is it? I don't wanna go there.
I couldn't tell you if I want to say South America, but I don't want to like disparage South America. I'm just here. I feel bad. I feel like I blame everything on South America now. And I'm like, it's no. And there are lots of countries in South America. Could be one, could be another. Okay. About 1.1 billion people live with an unhealthy air quality. Something like 75% of people in the United States are exposed to at least one day of unhealthy air quality here in the United States. And it contributes to about 7 million deaths a year. Some of those are directly air pollution caused, like it gave you cancer, or it has exacerbated emphysema or asthma to the point that it kills you on that particular day. And in lots of cases, though, this is something that contributes to the severity of pre-existing conditions. These are things that contribute to cardiopulmonary disease. These are things that contribute to stroke. These are things that contribute to heart disease. Yeah.
A little bit off, but is emphysema the one where they have to get like massages and stuff so they can clear their airways?
That's cystic fibrosis.
Does this affect cystic fibrosis?
Of course, yeah, it makes it much worse.
I was saying, I couldn't remember what it was. I have a couple friends who have cystic fibrosis.
Yeah, it's a genetic condition where you make too much mucus in all the places in your body where you make too much mucus. So we're really familiar with the chest compression or the devices that help loosen mucus in the lungs, which is where it's really problematic too, to cough it up. But you get excess mucus in like your digestive tract and causes digestive problems. That's exacerbated by these types of air pollutants that irritate that system, causes you to more mucus.
I'll say, my friend that I went to high school with, he actually moved, he couldn't even live
Yes.
here.
Yeah.
He moved out in the middle of nowhere.
Yeah, yes, exactly. But for cystic fibrosis patients, that serves kind of two things. One, it takes you away from these possible contributors. The other thing is it helps isolate you from other people, so you're less likely to get a bacterial infection. And because they have trouble clearing the mucus in their lungs, these bacteria sit and then cause really severe body infections, which is usually what leads to the eventual downfall of cystic fibrosis. They get an infection, I think.
So my life expectancy was like 36.
Wow. That's very true. Like most cystic fibrosis patients today really can expect to live into their late 20s to early 30s. And that is something that has come with modern medication. I mean, it used to be that was a life sentence in your teens. And so it's really dramatically different today. So, I don't mean to be glib about it. I have a really good friend. They have cool vests that do these sessions. But they have to be in those vests for like 4 hours a day. Okay. Again, we have about 43% of the U.S. population is exposed to dangerous air pollutants levels every year, and 14% of the U.S. population on any given day. Okay. Again, behind poverty, Air pollution is a major contributor to worldwide mortality. One of the UN's huge goals is to reduce air pollution because it contributes to so many deaths. Okay. All right. Again, what does air pollution do? It really relates to heart disease and stroke. It contributes to chronic obstructive pulmonary disease, COPD. It is now the leading cause of lung cancer. Tobacco smoke is usually the leading cause of lung cancer, but today that's been pushed to air pollution exposure. And it's a real problem in acute lower respiratory infection causes in children. And again, here the two different lines are where that air pollution is coming from. The green is outdoor air pollutants. The blue are indoor air pollutants, just kind of starting to separate these two kind of differences. This data is coming from the World Health Organization in 2012, so it may have changed just a little bit. But again, in terms of thinking about where are people dying because of air pollution, it's due to heart disease, stroke, COPD, it's a linkage to cancer, or it's a contributor to a respiratory infection that they get. If nobody's birth certificate really has on it, died from air pollution, okay? They died from a stroke or a heart attack. The cause of that was exacerbated by exposure to air pollution. Look. So radon gas, carbon monoxide, CO, so everybody has a carbon monoxide detector in their house, and they should do smoke detector. Yes, okay, if you need one, come talk to me. I'll get you one. Indoor air pollution, for most people in the developing world, this is wood or coal fire cooking. And so they're exposed to all of that type of industrial smog and air pollution actually in their home, where it sits and they breathe it hour after hour after hour. And so it particularly affects women and children that tend to spend a lot of time indoors involved in the tasks where we see these air pollutants generally.
So what kind of like,
Yes,
My mom,
oh yeah,
like when I was little, my mom changed my phone number, so that was a big thing.
yes, yes. Your ventilation system for your house has a filter in it, right? The air filter, it needs to be changed like at least every 6 months. Okay, it is catching a ton of these air pollutants, both that are coming in from outside of your home, and then as the air gets circulated, it goes through that filter too, and it helps to clean the air in your house. Okay. All right, where are people dying from air pollution? These are kind of global deaths in 2013. Again, responsible in 2013 for 5.5 million deaths. That's definitely up to 7 million today. The countries that are in red to orange colors have the greatest health impacts from air pollution. What are those countries? China. India. What is that?
Why are we the only white country? Why are we one of the only white countries?
Because we're stupid and we don't want to give them the data.
You right.
Is that what it is? We didn't get the data?
Yeah. We do a pretty good job with air quality in the United States, and we have reduced tremendously our sulfur and nitrogen burden in the atmosphere, which are major problems for human health concerns. We've done a pretty good job with carbon dioxide until just the last couple years, when it's ticked back up here in the United States. And so what's actually happening here in the U.S. is pretty good when it comes to air quality. And the big problems are in developing countries where you see large populations of people that are directly exposed to manufacturing industrial smog or indoor air pollution from home fires.
Kind of gives me, this is like, the countries that are basically doing all of the producing of the goods
Yes.
are the ones with this. Somebody that's doing.
Right, good. And so again, you can think that it used to be that in Europe and the United States and North America, we were doing all of these manufacturing to produce all of these goods, and we were exposed to the air pollutants. When those manufacturing processes moved overseas, okay, then those populations started to be exposed to those same types of air pollutants, and that's who there's the air pollution burden today. They're manufacturing goods for themselves and for us. Okay, again, that idea that the electricity generated in China is for that population to improve their quality of life. They're making goods to sell to us, okay? We bear some of this burden. So, the question now is, how do we stop this from being a more problematic in places like Africa and South America that are on the cusp of major industrialization? How do we prevent them from becoming the red and orange countries of 2030?
Why not? I mean, obviously the United States can't do like everything, but we have the regulations that say you have to have certain filters and whatnot.
Yes.
So why don't these other countries do that? I mean, China's like,
Good question. Why don't they?
Money.
Money.
it's
It all
not
comes down to
that
money.
bad.
It's bad enough. Okay,
Yeah,
it
how much
costs
they're
money
doing.
to install the filters. It costs money to run the filters. The filters take away energy that, in terms of electricity production, or it takes electricity and energy away from the manufacturing process. And for these companies, that's enough to say, we're cheaper, we're gonna make more profits, we're gonna be able to produce cheaper goods without installing these regulatory filters. And without government regulation, there's no incentive to do so.
Well, that's what I mean. It's like, what is the Chinese, like,
They have just recently in China passed some pretty stringent laws about air quality controls.
they've had people walking around, I mean, I've seen pictures of Chinese people with gas masks since I
Yes.
was like 12.
Yes, exactly. It has taken this long for them to take on this problem. It has taken this long for the Chinese people to say, this is a really major problem and you must deal with this.
Communist countries.
I haven't talked about China a lot, but India's like,
Yes, good. India's problem is manufacturing in their big cities, which is largely their southern area and around some of their big river systems. But out in the countryside, it's wood burning and coal burning, cooking fires. And so they have to move to centralized electricity in order to help with that. Not that I'm aware of. They tend to be a little more open to environmental regulation because their base culture is a little bit more accepting of those types of values. And not to say that Chinese base culture is not, but again, I would say like there's this dissonance lots of times between the Chinese government and the base populace of what they kind of want and what actually happens. I have a hard time because I'm like a utopian. I'm like, we should all share and we should all have everything. And like the base idea of communism is like, to some degree, and then I'm like, why does it always fail terribly when we try to
People are
implement
power
it?
hungry, but
Yes.
ideally, it's a
Right,
beautiful.
exactly. That's just it. It's like I have this problem with this idea of the idealism of communism, utopianism, and then like every time we try to implement it, it's just like a kick in the pants, and I'm like, man, now we have this bad name associated with
Canada didn't do a terrible job, but there's socialism.
it. Right, exactly. And I'm gonna say like then socialism is maybe the next step in the direction, and now that's getting a bad name, and I'm like, well, maybe I'm proud to be a socialist. I don't think I'm a bad person. Nor do I think that a conservative person is a bad person. Like, I hate that we started to value associate some of these idea labels. So that's something to kind of think about is that these different regulations that we see as being so important, how do we get them passed? How do we get them worldwide? How do we prevent places like Brazil and Venezuela, Ethiopia, South Africa from having real air quality problems as they industrialize? How do we get them to not even have these problems in the first place, to build correctly? Okay. All right. Again, outside air pollution is where we're really focused here at the start. It contributes to about 3 million deaths a year worldwide. Again, most of the problems with air pollution are happening in low and middle income countries. Air pollution is not an industrialized nation problem, with the exception again of China and India, which have these big populations and are moving into industrialization recently because we put in place these regulations about it. Again, what's problematic about this, stroke, heart attack, lung cancer, COPD, contributes to respiratory infections and disease. And again, China and India are definitely the hardest hit when it comes to 1 million deaths in China related to air pollution, 600,000 deaths in India related to air pollution. So again, if we were talking about human health, if we really want to improve quality of life, air pollution is one of these things that we have to tackle. impactful. It's one of these things we need to be really aware of, even though we tend to think of it after water pollution, trash litter, solid waste, land pollution, in terms of metropolis. Okay, here in the United States, this is 2013 data from our textbooks, looking at deaths per 100,000 adults per year, to which air pollution contributes.
I feel great. We're in the smoking pocket of the country
Yeah.
because West Virginia, Ohio, Kentucky, and Indiana are the highest smoking populations in the entire nation.
Tobacco use definitely contributes to this, and so in terms of in the U.S., indoor air pollution is tobacco smoke and secondhand exposure to tobacco smoke. We are in a population that smokes a lot. The other thing that's very problematic, particularly in West Virginia and Appalachia, is coal mining itself, the actual process of mining. And that has contributed, of course, to black lung disease and a variety of different types of cancers that are linked not only to the coal dust these days, which is filtered for, but to the silica dust that's associated with it. So where is it best, has the best air quality? Washington State, I like Nevada. No,
Oregon looks pretty good too.
And again, think about it, this is where you're getting the salt breezes that are coming right off the ocean, that are sweeping across those first kind of areas before they hit the Rocky Mountains, where you have, again, the best weather, climate conditions for low air pollution, in addition to less pollution.
Part of Florida, the Carolinas.
They're red as
They're
well.
like red and orange.
But they have the salt.
In those cases, it's not consistently onshore. It does this day-night cycle, where it comes onshore at night and it blows offshore during the day, but they don't have the consistent pattern of the blowing kind of off and on, with the season between. Okay, all right, where are we? Okay, the major air pollutants that we're gonna talk about, the major air pollutants that our textbook outlines that we're going to talk about just a little bit, each one of these in some detail. The first one that we're going to encounter is ozone, O3, and the recognition that it can be an air pollutant in the troposphere and is a protectant for us when it's in the stratosphere. We are also going to talk about nitrogen oxides and nitric acid. We're going to talk about sulfur dioxide. We are going to talk about carbon monoxide, and then we're going to spend like 4 classes talking about carbon dioxide pollution. We'll talk about particulates, we'll talk about those volatile organic compounds, and we'll talk just a little bit about radon gas, because it is slightly problematic in our region in particular, especially if you have a base. Caleb?
Where does carbon monoxide come from?
It also comes from burning fossil fuels.
But like, we have those in our houses.
Yes.
What in our houses is,
Your gas-powered water heater or your gas-powered furnace.
Where's my water?
And so if you don't have natural gas for those types of things, if you have a heat pump or if you have electric, you have a very low risk of carbon monoxide poisoning unless you have a fireplace, if you mismanage your fire and you're having an actual wood burning fire. Okay. There are big environmental questions that go along with this, like the carbon dioxide and the nitrous oxide and the sulfur compounds and ozone. Some of these are personal health safety concerns that we want to think about. Those are the radon gas and the VOC and the carbon monoxide. And so just like most things in this class, there are these 2 kind of scales that we're going to be operating on. And what's happening in your home, and also then how this impacts the greater ecosystem. Yeah, look. Oh man, it depends. I would say here in the United States, if we cut down on indoor air pollution, it wouldn't impact our overall air quality a ton. Because most people in the United States have some type of filter or ventilation system that's already operating in their house. And so the air turns over fairly quickly in your house, like again, depending upon how much your fan is on in 2 to 3 hours, and most of the stuff you're making in your house doesn't go outside already. For indoor air pollution in places like India and sub-Saharan Africa, where most of what they're doing for heating and cooking is biomass or coal-based, cutting down on indoor air pollution would radically change health outcomes. It is like a major contributor to early death, premature death. Very, again, particularly in women and in children that are exposed to higher concentrations on a more regular basis. Okay, let's start with ozone. Okay. Ozone is a compound. It is a molecule of 3 oxygen molecules. Again, we think of oxygen as O2, and that's the dioxygen molecule that we breathe in and we utilize in cellular respiration, given off by plants as an end product of photosynthesis. O3, though, is one of those molecules combined with another oxygen molecule. It is a somewhat odorless, colorless gas, but it is reactive. It will combine with other molecules in the atmosphere, both in the lower atmosphere as well as up above. Oftentimes you smell ozone after a lightning strike. So that big discharge of energy causes some chemical reactions in the air that it flows through, and you get this kind of really like characteristic thunderstorm smell that comes along with it. That's ozone. It's not terribly problematic, and it doesn't exist in very high concentrations in the lower atmosphere in the stratosphere. Okay, yeah, Caleb.
Is there a way to make ozone, like, because I know that
Not
there's
efficiently.
a patch, there's a hole
Yes,
in the ozone
yes,
somewhere.
in the Antarctic.
Yeah.
Yep. You can force the production of ozone like you can with most types of molecules and compounds, but it's very energy inefficient. So at the same time that you're like making ozone, you have a whole bunch of consequences that come with that ozone production, and then you have to get it in the right place and make sure it stays there. And that's also like, how are we going to make sure the ozone goes into the stratosphere and stays in the actual layer it's supposed to be? And this is kind of the dual nature of ozone. When it is in the lower atmosphere, in our kind of troposphere region, it contributes to photochemical smog. It can be a respiratory pollutant. Lots of times we get ozone on the weekends when everybody's out mowing their lawns and running their weed whacker, and then they use their little leaf blower to blow all the grass clippings in place. That produces localized little pockets of potentially damaging ozone in our layer of the atmosphere, and it's problematic when it's down here with us. And so again, the problem of creating ozone is the distribution. How do we get it where it needs to go, where it's safe for us rather than harmful? Yeah. It will eventually dissipate, but if it's in very high concentrations, you have the problems associated with it that are on the slide. It can contribute to these lung irritation and heart disease. The problem with ozone is not as severe for us as animals as it is for plants. And so here we have a plant that's been exposed to ozone, and you can see it causes the same type of wilting that you would get if it was infested with a disease or a type of parasite. And it eats away at rubber. And so that can be problematic again for like your car tires, or the belts in your car, or the belts in your machine. And so there are some of these like secondary effects of ozone when it's in our layer of the atmosphere that are particularly problematic. Okay. But ozone in the upper atmosphere is good for us. Okay. A small percentage of ozone in the atmosphere in total is down here in the troposphere. That's where it's problematic for rubber, lung disease, for plants, for respiratory ailments. But ozone in the stratosphere, where 90% of Earth's ozone does occur, is good for us. And that's ozone molecules absorb and block ultraviolet, UVA, and UVB radiation, particularly UVB rays. And this helps to protect us then from interaction with ultraviolet rays here on the surface of here. Okay? It acts like a natural sunscreen for us. And so it helps to prevent melanomas and skin cancers. It helps to prevent cataracts and overexposure to light. It helps to prevent kind of the photochemical overexposure to sunlight that plants and phytoplankton in particular can experience. Okay. So the ozone layer is up there in the lower portion of the stratosphere, and it blocks 95% of UV radiation that is coming from the sun. And this really has helped life to form and then prosper here on Earth, and again, it acts as a protective sunscreen for us. That without it, we'd have a variety of different problems with mutations in our cells due to exposure to ultraviolet light from the sun. It has been recognized that the ozone layer, particularly over Antarctica, which is the continent that's in this particular picture, has been thinning since the 1970s. So we've been taking measurements of the ozone concentrations in the lower stratosphere since the 1970s, and we pretty early on started to recognize that this concentration of ozone was shrinking. And this is somewhat seasonal. It happens naturally over both poles, that the ozone layer thins. But it started to happen a lot faster, and the extent of the area that was experiencing ozone thinning was increasing year after year after year into what we started to call the ozone hole, a place where there was very low ozone concentrations in the stratosphere over Antarctica and extending up into the southern portion of South America to cover most of Australia and portions of New Zealand, the Pacific Islands, and South Africa. And without that sunscreen, then, the people in the ecosystems of the Southern Ocean and these southern locations were exposed to higher concentrations of UV radiation. Okay. If this thinning and loss is most severe over Antarctica, again, the deep blue colors indicate very low ozone concentrations, up to 50% loss in the amount of ozone. You can see that the largest extent of this ozone hole actually was in the early 2000s, and it has shrunk considerably since then because of changes that we have made in our air pollutant emissions that were causing the thinning of the ozone layer. It's expected that if things continue as they are today, that the ozone thinning will be back to its natural process and course by 2050. Okay, like we're going to fix this problem that was occurring, okay, which is really a nice story in terms of air pollution and air pollution control. All right. There are certain communities that experience ozone thinning over certain cities, again, due to the production of types of air pollutants that are made either kind of upwind or in their location. So we started to notice that the ozone layer thins over places like Chicago and New York City as well, but it's not nearly as severe as what happens in Antarctica. Okay, it increases UV exposure when the ozone layer thins by 2 to 20%. What does this mean for us? Sunburns, eye cataracts, and skin cancers. And that happens in not only people, but in wildlife. Exposure to ultraviolet radiation can weaken your immune system and then make you more susceptible to infections and long-term chronic problems like stroke, like heart attack, like diabetes, the other things that your body is battling. It is problematic also for ecosystems. The overexposure to ultraviolet radiation affects primary productivity. In general, it tends to reduce it. It sunburns out plants. It sunburns out phytoplankton, which then alters food webs and ecosystems around them as primary production goes down. It contributes to other types of air pollution like acid deposition, photochemical smog. It can act as a greenhouse gas when it's in the lower portion of the atmosphere. So, my challenge for you for Tuesday, remember we're having a guest speaker, is that on Tuesday, I want you to bring in on a piece of paper the name of the legislation that solved the ozone hole problem. Okay, for extra credit on Tuesday, bring in the name of the legislation that solved our ozone hole problem. Okay?
In the United States or in the?
Well, it's a
It's
world
a
problem.
it's an international thing. That's it. It's international.
Google's it right now.
Yeah, maybe. Okay, all right. That's it for today. We are in chapter 18 of our textbook. This is where we will return to finish out air pollution next Thursday. Remember that Tuesday we have our guest speaker, and you can bring in the name of the legislation that solves the ozone hole problem for extra credit. Please take away some food today, and I will feed you again on Tuesday.